In this video, we're going to look at reviewing some of our processes to simplify rational functions. And to begin with, we're going to do two problems where we simplify by factoring. Now, the process of simplifying is as such. If you have more than one fraction, you want to put it together. If you have one fraction, you want to see if there's a way to make it look a little less complicated. And so I'm looking at this problem, and I need to attempt to factor it to see if anything will cancel. And so the problem factors to this. 3 minus x times 9 plus x over x plus 6 times x minus 3. Now, a common mistake is some people will try to cancel out these two factors with the 3 and the x in it, when in fact they're not identical factors. See, this is 3 minus x, that's x minus 3. So what I could do is I could do an algebra trick where 3 minus x, if I rearrange the terms, is the same thing as negative x plus 3. And then if you factor a negative out, that makes x minus 3. And then I've created the identical factors I need in order to cancel. So I'm going to rewrite that term, the 3 minus x, as negative 1 times x minus 3. And then I'm going to write everything else around it. Now we can cancel out. We can cancel out the x minus 3's. And in doing so, we're left with negative 1 times 9 plus x over x plus 6. And that's about as simplified as it gets there. Now let's do another one. So kind of the same thing. It's all in one fraction here. I need to see if I can't you do some factoring methods to see if we can't cancel. So let's try to factor the numerator and denominator to see what we can get. Now, I look for common factors. There's not really much I can do in the numerator, but the denominator has a common factor of 4. So I can help myself out if I pull out 4 and work with the trinomial 4 times a squared minus 6a plus 5. And so it factors this here. Now we look and we have identical factors that can cancel. I can cancel out the a minus 5's and then write what remains. And what remains is 3a plus 7 over 4 times a minus 1. And we've simplified the problem. Okay, now let's look at a problem where we are looking to multiply two fractions together. Now, before you jump right into multiplication, it's often helpful to try to factor both of these fractions here, and then hopefully some things will cancel as we start performing the operation. So step 1, factor and rewrite your problem. Okay, so it factors, both of the rational functions factor into this. And we look, and we can simplify this problem. The fraction on the right has a common factor of n plus 2, so I can cancel them out. Now, what we have is we're looking at the product of those two rational functions, and we multiply straight across. And so we're going to write our product as n minus 8 times n minus 5 times n minus 7 all over the product of 3n times n minus 7. Now that we've done the operation, we look to see if we have factors that can cancel again, and we do. The n minus 7's can cancel, and that leaves us with n minus 8 times n minus 5 over 3 times n. Okay, now let's do a division problem. So similar to with multiplication, before you do the operation, factor everything and see if you can't simplify your problem. So I'm going to start factoring my problem. And so I factor this problem, and we look and see it actually is going to reduce quite nicely for us. I can cancel out the v plus 2's in the fraction on the left, and the fraction on the right I can cancel out the v plus 6. And then we have a condensed problem to work with. Now, when we multiply fractions, remember we do skip, change, or excuse me, when we divide fractions, we do skip, change, flip. It's really multiplication by the reciprocal. So this problem becomes 7 over 1 times v minus 9 over v minus 10. And then now we multiply straight across. And so our answer here is 7 times v minus 9 over v minus 10. Now let's look at a problem where we are taking two fractions and we're adding them together. So in order to add and subtract fractions, you have to have common denominators. The easiest way to do this problem, or these kinds of problems with rational functions, is to let the common denominator be the product of the two denominators. And so what we're going to do is I'm going to take the denominator on the right-hand side, the x plus 5, and I'm going to multiply the fraction on the left by that denominator. So x plus 5 over x plus 5. And the denominator on the right-hand side, or excuse me, the denominator on the left, I'm going to multiply the fraction on the right by it. So I'll multiply top and bottom by 6x minus 5. So that way we have common denominators everywhere. Now, let's go through and let's multiply everything together. And so we'd have 4x squared plus 20x over x plus 5 times 6x minus 5 plus 18x squared minus 15x over that same denominator. So x plus 5 times 6x minus 5. Now, since the denominators are the same, we can now combine these two fractions and perform the operation with their numerators and rewrite. And so we add these things together. That gives us 22x squared plus 5x over x plus 5 times 6x minus 5. And then I do a quick check to see if maybe I can get anything to cancel. The only thing I could do is maybe factor out a common factor x, but that's not going to help me reduce my problem anywhere. So I'm going to leave it like that there. Okay, let's do another one here. Let's actually do the subtraction of fractions. Now the process stays the same. So in order to subtract fractions, I have to have common denominators. So my common denominator is going to be the product of the two bottoms. So I'm going to multiply the fraction on the left by the denominator on the right. So n minus 5 over n minus 5. And the fraction on the right-hand side by the denominator of the left. N plus 6 over n plus 6. And then I'm actually going to go ahead and do the multiplication. So we're going to have n squared minus 6n minus 5, so it's minus 11n plus 30 over those denominators. Now, I'm not going to multiply out the denominators. I'm going to leave them as a product. Because maybe, not always, but maybe I can get something to cancel when I actually put the numerators together. So minus, we'd have n squared plus 2n minus 24 over n minus 5 times n plus 6. And now let's do our operation on the numerators because they have the same denominator, so I can take the two tops and perform that operation subtraction. So the n squareds would cancel. Negative 11 minus 2 makes negative 13n's. And then 30 minus negative 24 makes positive 54 over my denominator of n minus 5 times n plus 6. And I'm not going to get it to cancel any farther or simplify any more than that right there. All right, now let's look at complex fractions. And they're not just called complex because they look hard. We have fractions within fractions, and we need to go through how would we work with this? Well, one of the first things to remember is that this line here within a fraction stands for division. And a lot of people forget that line means division, which means that I really could for some of these problems, like this one, is I could rewrite it as u plus 3 divided by 2u plus 1 divided by, you can write it with old school division sign if you wanted, 9 over u plus 3. And then when you divide fractions, you're actually multiplying by the reciprocal, so I do skip, change, flip, u plus 3 over 2u plus 1 times u plus 3 over 9. And then now we multiply our fractions, top times top, bottom times bottom, and go from there. So then we're going to have u squared plus 6u plus 9 over 18u plus 9. And that's about all we're going to do. Now let's look at one that's even more complex here. So not only do I have the division part like we had in the previous example, but I have two fractions subtracting in both the numerator and denominator. So what you do here is you are going to need to treat this like two separate problems. So I'm going to look at the numerator and I'm going to look at the denominator separately. Okay, so my numerator and my denominator separately. All right, so let's start with our numerator here. I need to take those two fractions. I need to combine them into one to try to simplify. So through the process of doing that, I need to get common denominator. So I'm going to multiply the fraction on the left by 2y over 2y. And multiply the fraction on the right by the denominator left, 2 plus y over, or excuse me, yep, y plus 2 over y plus 2. And now, work to simplify. So that's going to give me 8y over 2y times y plus 2 minus, now, I might as well go ahead and multiply it together. I'm going to have to do that at some point anyway. So y squared plus 5y plus 6 over 2y times y plus 2. And then put together the numerator since the denominators are the same. So we have, we'll have negative y squared plus 3y minus 6 over 2y times y plus 2. So that is my numerator. Now, we got to repeat all this for our denominator. Try to condense it. So what we have is, we have y plus 2 over y plus 3 minus 1/2. I need to get common denominators. So multiply the fraction on the left by 2 over 2. The fraction on the right by y plus 3 over y plus 3. And then work from there. So we'd have 2y plus 4 over 2 times y plus 3 minus y plus 3 over 2 times y plus 3, which is going to give us, we put all that together, we'd have y plus 1 over 2 times y plus 3. Now that we have our pieces condensed here, let me block this one in. We are ready to do the division of top divided by bottom. So when we do the division, top divided by bottom, I have negative y squared plus 3y minus 6 over 2y times y plus 2. So top, and then divide, skip, change, flip, be times, flip my denominator, so 2 times y plus 3 over y plus 1. And then we times those together. And what I'm going to do is I'm just going to write this as the product of 2 times y plus 3 times our numerator on the left. All over our denominator, 2y times y plus 2 times y plus 1.